Welcome to the another session in Frontiers in CFD. This simulation is hybrid battery thermal management system using PCM and air as a working fluid. These are the objectives: to create a 3D geometry of lithium-ion battery with PCM and air as a working fluid, to generate the mesh, apply name selection on computational domain, to set up the simulation and visualize the liquefaction, cell temperature and the total temperature of system. Welcome you all. Today we will see the CFD simulation for hybrid battery thermal management system, which involves PCM plus air. So we are going to use the arrangement which is represented like this. So let's start with the workbench window. First of all, we will prepare the geometry with the help of design modeler, and then we will proceed for the rest of the part. So this is one of the reference paper which we are going to follow. Again, we are not going with the exact dimensions of that. We are making some changes as per our requirement, and accordingly we'll proceed for the simulation. So it has shown around total 6 number of cells, but we'll limit ourselves to around 3 number of cells, and we'll try to visualize the simulation. So the workbench window has opened. Now you can click on Fluid Flow Fluent. Click on New Design Modeler Geometry. First of all, we will prepare 3 such cells, including a PCM as well as the casing which has been provided, as you can see in the paper. So we have the battery, then we have the phase change material, and lastly we have the copper enclosure and air the flowing from inlet to outlet. So based upon that, we'll going to proceed for this. First of all, set the units to millimeter. Click on any one of the plane, let us say X, Y and Z. So you can see here. So first of all, create a primitive, that is a box. You can see a wireframe model has been prepared. So the dimensions of the box, I will take X component to be equal to 154, Y component I will take to be equal to 70, and Z component I will take to be equal to 52. Instead of add material, I will select it add to frozen, and let's make it generate. So this is the box which has been prepared. Now on this box we will prepare sketches for your cell, then casing, and for your PCM. So accordingly now we'll do the modification in the geometry. So first of all, I just go to ZX plane, and on that ZX plane we will prepare the sketch. So click on sketch. So you can see, go to the sketching option available. So first of all, draw any circle on this object here. Dimensions of the circle, diameter we will take it around 32. Then we will decide the distance from one end. So select the center of the circle and this. So we'll define this distance to be equal to 29 here. Similarly, center and this distance we will define as 26. So this is the first circle we have done. Similarly, I need 2 such circles. So draw any line here. So the separation between them, we want a 48 here. So let's put it 48. Then one more line I will draw here from this to here. This will also be separated by a distance that is equal to 48. So 3 such lines we have tried to draw. Now I will try to draw again circles. So let's click on copy, set paste handle, and just click it at the required places. So in this way we have generated 3 circles over here. Now if you want, you can directly go and click on extrude operation as well. So just check. So you might need to remove the material which is provided here. So go to the modify, go to the trim. So this is not required, this is also not required, this is not required, this is not required, this is not required. So now I can go with the extrude operation. So click on sketch 1. Instead of add material, I will make it slice material. Take this is equal to 70 and just observe what changes occurs in the geometry. So you can see this has been separated out. Now this is for your cell. Now second thing is for your PCM. So if you just remember, this is 32 we are taken. Now I go with one more sketch on ZX plane. So sketch 2. Now go to circle, draw one more circle here. So the dimensions of that circle will take it 38. So 32 was the first, now this is 38. Now we have to draw 3 such circles, make it copy, set first handle and paste at the required places. So in this way we have drawn the 3 circles. Now one more time go to the extrude operation, select make it apply, instead of add material make it slice material and generate. Now you can see this is separated out from the rest of the part. So this will be your PCM. Now the third step we have to go is to have the casing. So one more time click on ZX plane, one more sketch we need to draw. So this will be your sketch 3. One more circle I need to draw. So this circle now will be of diameter equal to 40. So let's put this is to be equal to 40. So this will act like a casing. One more time go to copy, select this, set paste handle and then go to required places and put the casing out here. In this way we have generated casing. Now one more time you have to do the extrude operation. Instead of add metal make it slice metal and generate. Now these 3 parts will be separated out. This is your casing, this is your PCM and this is your cell. So to avoid complexity, let's denote this parts here. So this is your PCM. So I just sorry, this is your fluid. So I put it fluid here and you have to change the definition also to fluid. Then this is your casing. Okay, we'll select one by one circle. So this is, I will make it form new part. So I will define this as cell. So you can see here. So this is the cell, this is cell and this is cell. So you have to define the name as well. So let's put cell. Here also I will put cell and the third place also I will put it cell. So these are the 3 places I have put 3 cells. Now this is your casing. So first define the PCM and then we'll proceed. So all these 3 are your PCM. So make it form new part and denote that as PCM. So whatever the object we are having in that, you have to define this as a PCM. Ensure these are all solids. Let's make it, give the name and lastly put it here. So all these are PCM. So this is your casing, this is your casing and this is your casing. So one more time form new part. I just put it the name as casing. So you need to define it for all others remaining present. So here also you define it casing. Here also you need to define it casing. And lastly also you need to define it casing. So we have cells, PCM, just check out. So all of them are cell. Then PCM, all of them are solids, PCM, and then lastly your casing. So fluid zone only you are observing, this is different. Now you can go to the workbench window and save the work. So give the name hybrid battery thermal management system 3 cell. So one more time I just go to the geometry and will understand few things. This is a sketch one which represents your cell, which is of just check out, this is 32 is your diameter. Then sketch 2 is your PCM, so this is 38. So 32 and 38, that is equal to 6. So we can have 3 mm thicknesses on both sides, so that it will become 68. Lastly, this is 40, so this is 38. After that there is 1 mm of thickness which is on other side, and accordingly we are having this geometry. Now let's proceed for your mesh. Just click on edit. Wait for the mesh to open, and then accordingly we'll proceed. So right now if you just observe the geometry, so the last part is of 40 and the center distance between the cells are 48. Okay, if it shows some error, you just close the window and open it again. So let's click on mesh and click on edit one more time. Now you can see the window is visible and object is also visible. So let's generate the mesh first. We'll try to have a proper fine size of mesh so that there will not be any errors. But at the same time we'll try to ensure that uh, we are having limited number of nodes and element also. So let's put the element size to be equal to 0.001. So this count will change now. Let's click on generate mesh. Just see what changes occurs in the geometry. So you can see the mesh has become fine. If you want, you can put it further like 0.0005 also and generate mesh. Right now it is 8,70,000. If you make it further fine, there are chances this count may go more than 10 lakh. But if you are using the student version of ANSYS, the limitation of using the nodes and element are only up to 10 lakh. So let's see what is the count now, and accordingly we'll proceed for the next step. Okay, so mesh count has been very significant here. So this looks to be very fine, 58 lakh 11,000. So this may take some very long time to run the simulation. So I will not prefer to go with this very fine size of mesh. I will just check out with 0.0 00075 what is the count here, and accordingly will proceed. So this is around 19 lakh 81,890 is the present count which is available. So we'll proceed with this particular count, or if you want you can change the count also here to reduce the time which is required. So click on create name selection. I put it inlet. Similarly I will put it on the other side, that is as outlet. Now go to your geometry. I will select cell. I will hide all other bodies. Then I click on select all. So I now give it as name as cell boundary. Similarly, now show all bodies. I click on PCM and I click on hide all other bodies. Then click on select all. Create name selection. I will write as PCM boundary. So we are done with inlet outlet. This is inlet outlet, then cell boundary we have specified, PCM boundary we have specified. If you want casing boundary, you can also define casing boundary as well. Now click on update. You will see the mesh translation to Fluent successful message will appear here. Okay, you can see the mesh translation to Fluent has been successful. So click on save button, and then you can close the geometry and mesh window. Okay, so close this window, it is not required anymore. You can close the geometry window also. Let's open the setup part. Click on edit. Select the number of solver processes. I will put it to around 16. Click on double precision and click on start. Now the Fluent window will open. So one by one we'll do the setup part. So you can see the arrows which are from inlet to outlet. Click on OK. Click on this. Click on transient. Click on gravity. I put it minus 9.81. Then go to the models. Click on energy equation. Turn the energy equation on. Go to the viscous, K epsilon, enhance wall treatment, thermal effect, and curvature correction. Make it OK. Then solidification melting. Click on solidification melting and turn this equal to on. Then go to the materials. Now we need to define the materials. So first of all, I just go to the here. I will specify PCM liquid. Let's use PCM liquid. I will use the properties of PCM now. Density I will put 870. Specific heat 2570. Thermal conductivity 0.16. Viscosity 0.00137. Then pure solvent melting heat. Then solidus temperature 306. Liquidus temperature 307. Click on change create. So this is the paper which we are going to follow. We have not used all the same dimensions over here. We have made some slight changes, and accordingly we are going to proceed. Okay, so let's come to your Fluent setup part. Once this is done, close this. Click on this fluid. Click on air, which we are going to make use of. Make it copy and then click on close. Then click on close. In solid, I will specify lithium battery first. Here also I will specify lithium battery. So enter the 2879, then 880, then this is 0.743. Click on change create, make it OK. Then click on solid again, go to Fluent database, go to solid, click on aluminum, click on copy, and then click on close. Now one more time, just go and specify here as a PCM solid. Let's define this as PCM solid. So now we need to enter the properties for the PCM solid. So density is 900, then 2570, and let's put the value 0.2 thermal conductivity. Make it change create and OK. Now go to the database. Again we need to add solid material, let us say copper. Make it copy and then click on close. This is for your casing. Go to the cell zone condition, click on zone type, PCM. Now I will change this to fluid. So select the fluid, go inside. You have to properly do this selection. Put it air, make it apply, and then click on close. Then click on PCM, click on edit. So it should be a PCM liquid. Then click on apply and click on close. For casing, your material should be there. Casing material is copper, make it apply and then close. Cell material, it is a lithium battery. Click on source term. I go to the edit, click on here and then click on constant. So for cell we need to put the heat source term. So that value we will like to put 95,000. So 95,000, this is the value we have put as per the paper. Make it apply and then click on close. Go to boundary condition, go to the inlet, click on edit, enter the value to be equal to 0.5 meter per second, make it apply and then close. So go to the cell boundary and check out the respective required material if it is present or not. If it is not there, you have to change the material as per the requirement. So lithium battery is there as per cell boundary contact region also. Just check once and then we can directly jump to the next part. Okay, so for cell the boundary, the material is proper. Only now PCM boundary contact region, you have to select the required material. So I will select PCM solid, make it apply, close, make it apply, close. Go to PCM boundary, go to edit, go to thermal, select PCM solid, make it apply, close, make it apply, close. Third one, again you have to select the required material. I select the PCM solid, make it apply, then close, make it apply, close. Then PCM boundary contact region, one more time we'll do the same process. Check for your material. I will select the PCM solid, make it apply, then close, close. Then one more time PCM boundary is available. Go inside, thermal, select PCM solid, make it apply, then close, make it apply and then close. Go to PCM boundary contact region one more time, go to thermal, PCM solid, make it apply and then close, make it apply, close. Now cell boundary one more time, just check out. It should be lithium battery over by default material. It is there, no need to change. Go to PCM boundary. By default the material should be PCM solid, so we have to change it here. Make it apply and then close. Go to wall casing, click on edit. So casing is made up of copper, so make it apply and then close. In this way we have done the boundary conditions. Then go to report definition, So I will suggest to go report definition at the last. So first of all, click on initialize. Once the animations are visible, you can go back to report definition and set the required graphs wherever we required. So first of all, click on auto save, go to solution animation, then click on new object. I will select contours. So I select temperature. Here I select total temperature. I selected all. So this will be for all system. Click on float in order to make the scale normal. So click on this. I will put total temperature system animation. Make it okay. Then click one more time, new object, contours. So I select temperature, then I select total temperature. Now I select all cell region, cell boundary. Click on float, make it apply, make it save display. Click on close. Now I will put cell temperature animation. Make it okay. Similarly, just once I will check out. Okay. Then one more time, solution animation, contours. Now I will select solidification melting, liquid fraction. Now where the liquid fraction will be available, it will be for PCM boundary. So I will select all PCM boundary region available for us. Then go to color map. Instead of exponential, make it float, make it apply. Click on save display. Click on close. This contour 3 now will be equal to liquid fraction PCM. Make it okay. Now animations are set, and now I can go back to report definition to prepare reports. So first of all, temperature I will select, then total temperature I select all. So I put it here, total temperature system, report definition, make it okay. Now one more I need to do. So here temperature, I select total temperature. Now I select it at outlet. So I put it temperature at outlet. So this is one more report definition. Now surface report area weighted average. I select temperature. I select total temperature. Now I will select only cell. Print to console. I will put at cell temperature report definition. Make it okay. Lastly, surface report area weighted average. I will select solidification melting. Where is the PCM? PCM is the region where the melting will take place. So select all. So put it liquid fraction PCM report definition. So let's make it okay. Now you can click on run calculation. I will take first 10 and then I will run it. This will take some long time till the solidification melting are actually been taking place, but we will just visualize which are the windows that will be visible for us. So when the first 10 iterations are completed, that time we will be able to visualize all such windows which are going to appear for us. So more the mesh count which you have taken, more will be the time required for the simulation. So you may go with a less number of count also, but there are chances that you may find some error in terms of floating point exception. So once this 17, 16 and all these are completed, we will be able to visualize the all graphs as well as all animation windows. So we'll have to wait. Now you can see the windows are appearing one by one. So we'll just understand how the windows are, then we'll proceed. So the first window represents your scale residual, which will show you the iterations which are been performed. The second window which shows you total temperature of system, you can see it is rising. Another window which shows you the total temperature at outlet. So right now it is showing 300. After some time you will see variation. Then cell temperature, again you will see it is rising. Then you will see liquid fraction. So right now it is showing 0. So the melting hasn't started yet. So that's why this will show you 0. Then this shows you liquid fraction animation. As of now there is no melting has taken place. Then this shows you individual cell temperature, and this will show you the temperature of entire system. So in this way we have to run it long time in order to visualize the animations, in order to visualize the liquid fraction and so on. So we'll keep this running for some long time. So we are running the simulation now. It has almost done for 35 seconds. You can visualize temperature hasn't reached much, it is just 310.31. You can see the temperature outlet is increasing. Liquid fraction you will see again 0 because the melting hasn't started. So we have to run this further in order to visualize the liquid fraction. The simulation has reached to around 148 seconds. You can see the total temperature of cell. This is the total temperature of system. You can see the liquid fraction which is not available as of now. It's a PCM not melted. Similarly, liquid fraction PCM, you will see 0. This represents the cell temperature which is rising. This represents the total temperature at outlet. And this will represent the scale residuals. So we need to run this further to first visualize the liquid fraction. So we have to run this further. Once the calculation is completed, we'll run it again. We can now visualize the contours of liquid fraction which is available. So here also some shades are been visible. Still it may take some time. You can see this, the curve is going up here. So in this way we need to run this simulation further in order to visualize significant solidification and melting. You can see this is a curve which is almost reached after 286. So we are run the simulation for almost around 450 seconds. You can see the contours of liquid fraction. Then the liquid fraction is also visible here. This will show you the cell temperatures. This will show you the total temperature of system. This will show you the graph temperature at outlet. This is your liquid fraction. So you can see the PCM has been melted. The figure shows a liquid fraction versus flow time. The figure shows cell temperature with respect to flow time. This curve represents total temperature of system with respect to flow time.